Okay. What the first one is asking for? Asking for X value or the Y value? Y value. That means this thing is X. And they want us to find out when X is 2, go to the graph and figure out the Y value. So this is 1, this is 2. When X is 2, it go down. And this is the Y value. It's -3. Anytime going down below 0, it's negative. That's why I clearly said this is -5. So this is -3. In the next one, they want us to find all the X values. That means what is this number? X or Y? Y. So when Y is 1, see how many X value you have. Y is 1 is here. So if you draw a line, we have one X value here, another X value there. It's a whole number. It goes straight down. Why can't you? See, this is clear. It crosses. It's okay.
I think I'm blind. I think I'm blind or something. I can't tell. Is that like a fraction or whole number?
I made Jannah so you can see that these and this are the same number. But anytime close enough, I'll give it the points. So this is 4 and this is 0, right? So we have X equals 0 and 4. 2 X values. Now the transformation. What is our original function here?
Like a B.
Original function is absolute value of X, right? Which is a V. So negative means reflection upside down. We have a +2 inside the absolute value. Which direction? Left. And you have a -3 single. Down 3. So combining all this information, this is X, this is Y. The original one is here. Now this original one, we are reflecting. And that reflection go 2 left, 3 down. So 1 left, 2 left, 1 down, 2 down, 3 down, somewhere here, and you're graphing. For now, no, it's okay. But in the exam, I'll tell you draw the original one and it's 1 point. And the transformation is 3 points.
So it's going to be like just like show one. It's not going to be one.
Right. Like the, not the whole thing, it depends. Like for example, the left one, you have to write it down, right? The right one, you're graphing it. And for example, when I give you graph and say, are these function or not a function? You just have to write yes or no. Is this a function? It is, because if you draw a vertical line, it passes the vertical line test. So for those type of question, you decide whether the following graphs represent a function or not. You just have to draw a vertical line and then write yes or no. No justification is needed. Okay, any question? You'll see this again in the exam, okay? So we are actually, I am actually giving you in the quiz all the exam questions. So every quiz you see, those are exam questions. Let me actually return you second quiz. I decided not to count the first quiz because everybody failed except for one or two. So I was like, well, let me just hit that. And yeah. Yeah. So originally I decided there is no partial credit beside the 1 point or 0 point. And then when I see everybody got 0, I just gave that. So I said, well, let me make it 2 points. 1 point for participation and 2 points if you get everything correct. Okay. So based on that, well, I have only few zeros. If you did nothing at all, like no correct step, nothing, then you get 0. But if you should be at least some correct step, I give you 1 participation.
Wait, I was great.
The last one I'm not taking. So the last week. The second? Yes, you second one. Namely. Kevin?
Oh, I'm pretty sure I wrote it.
Yeah, by the final exam, no partial credit. Why they get it correct, 1 point, you get something wrong, everything is wrong.
The finals is not that bad.
Actually. Eight.
Yeah. Oh.
Continuing. Yanni.
All these things.
Yeah. Oh, Alex and Alex. Okay, right. Yeah. Okay, was find the public language. So we went over this in class. I have one, no name. Okay, I'll give you, but first tell me, what is 6 minus 6/5? That's what you think? 4 and 4 were 6. Okay. Now I believe you. But in the exam, don't do that. I want to see what, okay? It didn't write your name, so Jamil, right?
Why? That's really good.
Next to shoulder one.
So what are those five quizzes on the list, right? This can work. On the standpoint.
Rackspace, children, minus. Actually, I'm not comfortable with their, whatever they have.
Oh yeah, MATLAB has like five quizzes.
The 8.1, 8.2, 3.6. Yeah. 5.1 for and
So how much is that?
no, we don't.
How much did I
I don't know. At the end of the semester, okay, so it was a good practice. Now let's start the lecture. So in our last class, we talked about function. We talked about, let me give a brief recap. Okay, so we said a bunch of product here, they represent a relation. Among all the relation, if you don't have any repeated x, they represent function. If you have a bunch of order here, if they don't have the same x value, then they are function. If you have a bunch of graphs, all you have to do is draw a vertical line through the graphs. If you have only one intersection, they function. If you have more than one intersection, they are not function. And then the equation, which equations are function, we observe only the y, the power of the y. If y has an odd power, like 1, 3, 5, 7, those numbers, then they are function. And if y has even power, it's not a function. So if you don't see a y or y has even power, it's not a function. And we did a bunch of examples. Then we started doing evaluating function. It means the x values are given. We have to just plug in the x values and then simplify using pandas. Whatever we get, that's the y value we get. And then the last question we did was, again, it's evaluation, but it's not only a number, it's variable. F of x plus h minus f of x. It means in first step is substitute all the x with x plus h and then simplify. Once you're done with the simplifying thing, then you subtract the original one. When you subtract the original function, all the sign in the function will change, and then you collect like terms. So that was the last thing we did. Now today we are going to start with very same question, not same, but similar question. It says f of x is x squared minus 2. Now find what is f of 3 plus h minus f of 3. So we are going to do the exact same thing what we did before. Our first step is figuring out what is f of 3 plus h. Once you do that, then you're going to figure out what is f of 3. So you're going to find we're going to evaluate our function twice. Once by replacing x with 3 plus h, another time by replacing x with 3. And then you're going to subtract the second one from the first one. So first, we need to find what is f of x plus h. It means the x we see here, we are not going to write x anymore. We are going to write the whole thing. Sorry, 3 plus h. We are going to write whole thing in place of this x. So the original one is telling us it's x squared minus 2. But now we are not finding x squared, we are finding f of 3 plus h, means 3 plus h is inside. And then we have our square, and then we have minus 2. Now you're going to simplify. So since we have a square power, it's telling us, hey, multiply 3 plus h twice. This is what square power means. And then subtract 2 from that. So we do 3 times 3, 9. 3 times negative h is negative 3h. Plus 3 times h. Oh man, sorry, my bad. It should be plus. We are multiplying the exact same thing twice. Plus 3 times h, 3h, and then h times h squared. So I'm just foiling them out. And then from the result, you subtract 2. Do you see any like terms here, Roger? We can combine 9 with negative 2. And how about this? 6h. So this gives us plus 6h. 9 and negative 2 gives us 7. So we get h squared plus 6h plus 7. I just rewrote them in order. We have a single h squared. From combining h, we have 6 of them. And then from the numbers, we have 9 minus 2, which is 7. So this is our first term, f of 3 plus h. Now you're going to find what is f of 3. Seconds. That means we're just going to replace x with 3 in the function. So our function says x squared minus 2. But instead of x, what you're going to write? 3. And it's just numbers. What is 3 squared? 9. 7. Now, finally, we rewrite final. They want us to find the first one minus the second one. The first one is this thingy we found. H squared plus 6h plus 7. We are subtracting. The second one is this 7. And then we just collect like terms. Do we have any like terms here? Plus 7 minus 7. What happens to them? Cancel. H squared plus 6h. In the final exam, you'll have to give this question. And when you take pickup class, you're definitely going to work with this a lot. Yes. What's the next math? Pre-calculus. Either 2009, 2003, or they started a new pre-calculus 2001. So if you're kind of weak in your math, 2001, they said is better for you. And 2003, 2009, they're the same math. Just 2001 is a little bit different.
So it's,
2001 is more like trigonometry. 9 has more time, 3 has less time. Just like you guys. Here for 1030, the normal students, they get 1 hour 40 minutes twice per week. And 1023, they get 1 hour 15 minutes 3 times a week. So the same thing happens in pre-calculus. If you take 2003, it's 1 hour 40 minutes for normal student, but you guys are sick, so you're gonna get 2 hour 5 minutes for 2003. And in 2009, you're gonna get 1 hour 15 minutes 3 times a day, 3 times a week.
This is like the intermediate class.
Not intermediate. 2009, they have more time than 2003. Any question on this? Okay. Then we have absolute value function. The job for absolute value function is make everything positive. Okay, so it doesn't matter what number we put inside the absolute value. At the end, we're supposed to get positive results back. So f of x is absolute value of x minus 2. It says find f of negative 2. So you're going to substitute x with negative 2. Negative 2. And then we have an extra negative 2 here. What is negative 2 minus 2? No. Negative 4. So we have a negative 4 inside the absolute value. Absolute value says, well, I don't care about negative. When I give you something back, I always give you something positive back. So absolute value of negative 4 is positive 4 if you take out your absolute value. If you keep your absolute value, it's still negative 4. But when you take it out, it becomes positive 4. That's because absolute value actually tells us the distance from 0. So this is telling us we have 0 here and we have 1, 2, 3, negative 4 here. It says, well, the distance between 0 and negative 4 is 4 units. This is what absolute value means. What's the distance from 0 to the number you have? That's why we know distance is a real life scenario. It can never be negative. So when you pull out the absolute value, we can never get a negative result, negative number. You try the next two, find what is f of 0 and what is f of 7. Question, Nicholas, Aditya? Today is what, 9:10. Hailing absent, right? Daniela here, Alexis here, Sophia here, Evelyn, huh? Sorry. Yeah, I gave you an example. Please, but I totally forgot. Thank you. Sophia here, Evelyn here. Evelyn. Catherine Chen here. Sharon here. Kevin here. Emma here. Karen Dahal. That's why you're always absent. Lucky you are here today. Kira here, right? Ibrahima here, Diani here, Alex here, Jonathan here, Fresherly here, Shinea. Okay, here. Nicholas here, Zakaria absent. Jean here, Roger here, Catherine Lynn absent. Jalen. Ariel here. Ashley here. Brenda here. Juliana here. Vianney here. Okay, so Vianney and Ashley. Okay. Niley. Brittany here. Aditya here. Jade here. Jamil here. Santiago here. Zayla Reynoso. Skylar here. Seeing here. Oh. Is there anybody's name I did not call? Right. Okay. We want to find f of 0. Emma. Okay. So I wrote down f of x is equal to the actual value of x minus 2. And then I put f of 0. F of 0 equals the actual value of 0 minus 2. 0 minus 2. Perfect. Wonderful. Good job. Finally, f of 7. Diani. F of 7. So what did you do? 7 minus 5. Sorry, 7 minus 2 gives us 5. Equal the absolute value out 5. Any question on the absolute value function? You might see this in the exam. Okay. And now comes one of the either hardest or easiest topic, domain and range. If you understand, it's very easy. If you don't understand, it's very complicated. Okay, but I don't understand why people find it complicated. Like, I don't see why they don't figure this out. So if you don't figure this out, please tell me why, so that I can see what's wrong with this, okay? And I can help you.
I'm assuming people get mixed up with like the negative. As you think about it, I feel like people like
Find out values.
Yeah.
Yeah, but how? Okay, domain, like we learned before, it's the x values. What x values you see in your function, or what numbers you're allowed to plug in your function so that you get a valid y value. Okay, so domain is all x values. So if you're observing a graph, you just have to see on the left side what is the smallest x value to, if you go on your right side, what is the largest x value you see. So domain is the smallest x value from the smallest x value to the largest x value in a graph. But if you are given a function, you just have to think which numbers we can plug in for x and get a valid y value. Not every function you can plug in every number for x. Okay, there are some functions you cannot plug in all the numbers. For example, square root of x. Can we plug in negative numbers in the square root function? No, right? Because if you do, -1 under the square root becomes imaginary number. It's not real anymore. So domain means what numbers we can plug in and we still get something real back. Range is the same thing, but you just observe the y values. When you plug in the x values, what are the y values you get? Those are the range. And if you're observing a function, the range is the smallest y value from the smallest y value to the largest y value. So you just have to see in a function, what is the smallest y value you see? And then the function going on. So you walk your function and see at the highest point, what is the y value you have from the y-axis. It sounds so easy. Then why people don't understand? Example here, domain. Domain means look at the graph and see what is the smallest x value you have till what is the largest x value you have. So it is in V, right? It keeps going on forever. When it keeps going on forever, what is the smallest x value you see in your function? For example, thank you. But if you did not understand, at this point, what is the x value? 5. Now let's move to left. At this point, what is the x value? And now keeps going on. At this point, what is the x value? Are you observing that the more left, the more left you are going, what is happening to the numbers? They are getting smaller, right? From 5, it's got 0, and then -2. The more you go, it will go more on the negative side. Negative, 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 negative. So in the negative side, what is the smallest number we have? -infinity. So even though you don't see it, but you assume that the line is going on forever. And for that point, what would be the x value? Somewhere on the value left to the negative side. So the smallest x value we have here, is -infinity. Now, same line is going on forever on the right side. That means we get to positive infinity. So our domain means what x value you see in the graph from the smallest to the largest. Smallest we see is -infinity, and we see all the numbers between them, and we see the largest one is the positive infinity. It's saying that, well, we're allowed to plug in any number from the number line in our function, and we are going to get a real number back. For example, if I say, well, what is the y value for x equals 5? Well, x equals 5 is here. Y value, we do have it, it's 3. If I say, well, what's x value we have on? X is 10. X is 10 here. You see, we have the y value here. So it doesn't matter what x value we put, what x value we look for in our function, we always have some valid y value. Now for range, is the smallest y value to the largest y value. So in this graph, what is the smallest point is? Here, right? And this is the y value 3. And then this line going on forever and ever and ever. So if you go the upside, the higher, what is the highest number you're gonna get? Positive. Because see, this is 3, right? The more you go for this point, this is 6. For this point, this is 8. The more you go, look at the y value. What is happening to the y value? They are increasing. So the highest one, we have no idea. So it's from 3 to infinity. Now here something interesting happens. This 3 is a number, not a symbol like infinity. When you have a number and that number has a closed circle, we had to write our boundary with a square bracket. So anytime we have a number and the number has a closed circle, means bracket. But if you have a number, it's not a closed circle, it's an open circle, that means it's a parenthesis. Open circle means the y value doesn't exist there. There is no y value. Bracket. Right. The parentheses don't include the numbers. Bracket means yes, the number we have at that point, we have a valid x value and a valid y value. Now tell me what was confusing. Anybody? Something was confusing, right? Brenda, starting with you. What do you think is confusing? I just want to see like what is confusing. Because I have to improve myself. I have to improve my explanation. So tell me what was confusing. So observe here, it's a number, right? So we have to stop there. Whenever you stop somewhere, it's a number, and then we have to use either bracket or parentheses. Bracket means if you have a closed thing. Close means we have an x value there and y value there. So we bound that by square bracket. Square brackets are very tight. So it means everything we have here, it's a real number. But there's some scenario you see that when you stop somewhere, it's a circle. Circle, you don't have a number there. It's empty. Empty means parentheses. Okay? Anything else? What was confusing? Any other comments? Santiago. Did you understand or did you not understand? Okay. Anyone else?
I don't think it's confusing. I think people forget the next thing. I mean, for real. Like, I feel like every time you go out of class, most people just forget. So I think you just gotta stay reminded. I don't think people are gonna be.
What do you think? Is it true? You're not confused, you just forget them. True? Right. Then let's see, how do you do this one? What's the domain for this function? If you understood, that means you can also give me the answer. If you cannot give me the answer, that means something you did not understand. So tell me what you did not understand. Remember, domain is the x value. For this point, do we have an x value? For this point, we do, right? Yeah. For this point, do we have an x value?
That's what it's.
For this point, do you have an x value? Every time you see a point, every point have an x and y value, right? So here, do you have an x value? So the line is going on forever and ever and ever and ever. What is happening to the x values? The more left you go, the x values are going toward which direction? Toward which number? What is the smallest number we have on the left side? Negative. So on the left side, we are going toward 1950. Now this one is going on forever on the positive side. So what is the largest number we have on the positive side? Infinity. So our domain is from negative infinity to positive infinity. Because as the line going on forever, every point we have in the line, we have an x value and a y value. X values gives us the domain. Now the interesting question, what is the y value? Oh, parentheses, maybe, comma, 3, parentheses, parentheses, 3, comma, other 30. You're telling me you see all the y values except for 3. The thing you told me, the answer, it means I see in the graph all the y values except for 3. No, I took the 3. Wait. So I said negative infinity to 3 in the parenthesis. Parenthesis means 3 doesn't exist in the graph. It goes toward the 3, but 3 is not a number in the graph. Because it goes towards the 3 and then it goes towards. If you go which direction you're walking, up, down, or left, right? Left, right means what? Domain or range? Which one? So if you walk in the graph from left side to the right side, you're giving me domain. Range is walking up and down. So it's 3. What is the only number you see, only y value you see in your graph? 3. So why there you put 3 comma
What's going on?
Oh. The only y value we see in our graph is this thingy. So our range, what happened to my pen? Oh man. So range means what is the y value we see? There's only one y value we see, it's 3. And since 3 is just a single number, so we actually use a new type of bracket. It's called curly bracket. If you have only one number in your domain or range, we represent that with a curly bracket. But if you have two things with parentheses or brackets. Any question? How about the next one? All right. Remember, domain means you're walking from left side to the right side. Range means you're walking from upward and downward. Ready? Skylar, what do you think is the domain? Domain means what x values you see. Do you see any other x values? Good. So domain contains only one number 8. So we are going to use a curly bracket to represent that. Helen, would you like to try the range? The range means from upward to downward, from the downward part to the upward part, how low you're going on the downside to how high you're going on the upside. Wonderful. I hope Skylar didn't give you the answer. Any question on this?
How come, wait, I forgot, I already forgot. But like, how come there's like curly bracket? Why do you have?
It makes you a single number.
So,
So what is the x value you see? How many x value you see?
I was, so,
It's only one x value, 8, right? How is it?
so whenever you, doesn't matter if it's still here. One
Right.
dollar.
Anytime one number means thousand. Two number means parentheses or brackets.
The parentheses mean that you don't include value,
Right.
and you see that,
Square brackets.
then,
Any question? How about the next? This line is going on forever. This line is going upward also forever. Ready? Karen, help me with the domain. What would be the domain of this function? Negative what? Negative 2 to infinity. Why you choose to pick negative 2? So when I say negative 2, this is the y value, right?
like 2, 4, 6, 8,
Okay. So this is negative 2. This is the y value, right? This is negative 4, right? Do we have a y value? This is negative 6, right? Do we have a y value? The line is going on forever. So do you have more x values on the negative side? So can you stop at negative 2? I think I'm doing great today. I'm understanding some of the questions. Negative. Negative infinity to positive infinity.
No, for the range.
Oh, you ready for the range? Okay. What's the range?
Soup. No, soup, bro. I think it's forward to infinity.
4 to infinity. Why did you pick 4? Well, remember, range is the y value, right?
Yeah. So the y, I'm looking at.
So this is 2, this is 4. When you have y value 4, we have a point in the line, right? How about when our y value is 6? Don't you have anything in the line?
Yeah.
When our y value is 8, don't you have our graph here?
Oh, never mind. It's negative.
You see, the line is going on upward forever. So y value is increasing forever. The line is going downward forever. So we have y value negative side going on forever. So it's from negative infinity to the positive infinity. Wait, so how would you actually bring out negative infinity, positive infinity? No, like, we don't have a number because we have all the numbers in our mind. Here, we don't have all the numbers in our domain. We have only one. So we wrote the number. Here in our domain, you don't have a number, 2 number, 3 numbers. We have all the numbers. It's negative to positive.
Are there any scenarios where the domain not
Yep. Yep. All these graphs I showed you, they're continuous one. So for continuous function, they goes on forever. The range gives us a y value, right? So for this point, what's the y value? 0, right? Now for this point, what's the y value? For this point, what's the y value? For this point, what's the y value? So how the y value is moving? Positive direction or negative direction? It's negative, right? So the more it's going down, the more it's becoming smaller and smaller. Now this line is going on forever. So if you remember here, what do you think would be the y value here? Any other question? Okay. Now comes some function, they're not continuous. So all these function I showed you so far were continuous function, means they go on forever, either left to right or up and down. Now this is a function, it's not continuous everywhere. Every time you see a hole, at that hole, it don't have any x value, it don't have any y value. That's why it's a hole, it's an empty circle, it's an empty spot. So do you see any point in the function where you have a hole? Where do you see a hole? At the origin. So x value should be 0, y value should be 0, right? But you don't have any x and y value 0 there. So when x is 0, no x value, no y value. It's an empty spot. But if you go to the left side, for this -1, do you have a point? For this -2, do we have a point? For this -4, do we have a point? And this one is going on forever and ever and ever. So if you have an x value there, are you going to get a y value on the up? Yes. So what is the smallest x value you see? -infinity until 0. So this domain is weirder than the one we did before. It's from -infinity to 0. And since 0 doesn't have any value, so you put a parenthesis. But we cannot stop, right? Because after 0, we still have a function going on forever. So from 0, what is the largest x value you see? Infinity. From 0 to infinity. So basically it's saying that in this function, you can substitute any x value except for 0. If you try to substitute 0 there, you're going to get nothing back. You're going to get an empty spot. So domain is from -infinity to 0. We stop at 0 because there is no x value at 0. And then again, we start from 0 and it go to forever to positive infinity. Any question on domain? These are finalizing question, guys. Okay, range. What is the smallest y value we see? We're supposed to see 0. We're supposed to see 0, right? But do we have any value for 0? No, right? So we start at 0, but since there is no place for 0 there, so it's a parenthesis. It's not -infinity. In order to have -infinity, you have to the part here on the downside, part of the function, part of the graph. But there is nothing below your x-axis. So there is no negative y value in our function. We start from 0, but we cannot take 0. What is the highest y value you see? Infinity. And if it is a symbol, it always gets parentheses. Unless you take calculus, I don't know. Huh? Why is it? Do we have a number at 0? But do you have a function at 0? So parentheses means you don't have a place for that number.
So the reason why the link did not stops at 0 is because it's not one straight line.
Right. Because there is no straightness, there is no continuity here.
So
it stops and then starts again. So every time you stop somewhere, you have to pause. You have to break your domain. So we stopped at 0, we have to break down our domain. Unlike the other ones. The other ones, they were continuous forever. So it did not stop anywhere. Looks complicated. But all we have to do is keep what? So this one is going on forever, right? So what is the smallest one x value is supposed to have? Okay, so we know this portion starts from negative infinity. So we are starting walking from negative infinity. We walked and walked and walked. And then what is happening here? We stop, right? Because there is no value there. What's the number here for x? 0. So from negative infinity to 0, and 0 has to add a parenthesis because there's no number there. Here, there's a number. So it stops at 0. And then suddenly we jump down to this point. And this point, do we have a 0 there? Yes. So we start from 0. Since we have a number, so we put a bracket this time. We started from 0, and then we are again one. So this side is going up, means we have x values from here to there, right? For this, we have x here. For this, you have x here. For this, you have x here. For this, you have x here. So for this portion, our x values are from 0 to 1. Do you see that? So we walk from 0 to 1, but then you have to stop again, right? Because there is no next part. Okay. So for this portion, it's 0 to 1, and they both are in the bracket. And then suddenly again, what you're doing? Jumping down. We jump down. We still have our x1, right? But do you have any value at 1? No, it's empty. Since it's empty, so we are starting from 1, but this time it's parenthesis 1. And this one is going on forever and ever and ever. So we are walking forever and ever and ever. What's the largest x value we have? Infinity. So we have 3 parts, 3 domains. Now let's combine them. We have negative infinity to 0. Now let me write it here. We have negative infinity to 0. And then we have 0 to 1. And then we have 1 to infinity. Right? Okay. So this is how we stop and start, and then keep going on forever. Now, if you combine all of these, are you actually stopping anywhere? Like, you're supposed to stop 0 here, right? But in the next one, we do have a 0. Do you see that? In this portion, we don't have a 0. But in the next one, we do have a 0. So the story is this. From negative infinity to 0, we walked, and then we start because no x value. If you go down, it's negative infinity for y. But when you go down, you're observing our x-axis. For this point, this is our x value, right? For this point, this is our x value. So when you walk down, look at the x value. In that x-axis, which direction you're going? Okay, so you're walking from negative infinity to 0, you stop. But then start from 0 again. You are walking to 1, right? And then at 1, for the next level, we don't have anything, and you're going on forever. This is our x-axis, right? From negative infinity to 0, we start at 0, but in the next journey, we started exactly from 0, and we went to 1. And then the next journey, we started from 1, and then we went on forever. Because I'm not done yet.
Oh, but that goes in the.
Yeah, that will. I'm not done.
It's been young time.
Did a financial question. So if you observe your x-axis, from where till where you walked. Look at the x-axis. You started your journey from where? Did you stop anywhere? Did you have any gap in anywhere in that x-axis? No, right? Even though we have a gap here, but when you filled one gap with the closed one, there is no more gap anymore. So it's actually from negative infinity to positive infinity. So our real domain from negative to positive infinity. It's a tricky question. Every time you stop, since you are starting from exact same place, that means you're not leaving your spot. You don't have any gap in your journey. You started your journey from negative infinity. You stopped at 1, so you stopped at 0, but again you started your journey same place, from the same place. So you did not have any gap in your journey. You went to 1, you stopped. But in the next journey, you started from your 1. You did not start from 2 or did not start from 3. You started exactly from 1. And then you went on forever. So we don't have any gap in our journey. Even it looks like we have so many gaps, but when you combine it together, no gap. So our journey started from negative infinity, ends at positive infinity. But range will not be same. Because look at the range. You're starting your journey from the lowest point. What is the lowest point you see in your graph? Negative infinity. Let me change color to something like this. Bless you. So actually, let me write this way. So you started your journey from negative infinity, and then you went up, 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 and then you stopped at negative 1. So negative infinity to negative 1. Since negative 1 doesn't have a value, so negative 1 gets a parenthesis. I'm writing this way, okay? And then did you start from negative 1 again? No. So you definitely have a gap this time. So once we reach negative 1, we took a gap, and then we started our journey from 0. And this 0 is included, so it gets a bracket. And now we are moving up, 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 until we reach at 3, right? And then we stop again. Since we stopped at 3, So for this journey, we went from 0 to 3. Did we set our next journey from 3? No. So we have a gap now. Where from we start our journey? Positive 4, right? So we started our journey from 4, but we have a gap at 4, right? It's the open circle. But then, did we go up anymore? No, right? So once we reach 4, we stop our journey. So 4 is a single number, right? And for a single number, it doesn't matter it's contained or not. It's curly bracket. So if you combine together our range, we started from negative infinity to negative 1. Then we stopped from 0 to 3. And then at 4, we stopped forever. Can you combine them? Like domain? We cannot because we do have some gap in the ones. From negative 1 to 0, we did not walk. We flied probably. And then from 3 to 4, we did not walk.
When are the y values going to negative?
Can you give me the y value negative 0.5? Do you have a journey for y value negative 0.5? Then can you include that? Do you see my point? We only include where you walked. So we walked from negative infinity to negative 1. But we did not walk from negative 1 to 0. And then we walked from 0 to 3, but we did not walk anything from 3 to 4. So we cannot put them together like our domain. Look my domain. I marked where we start and where we started. But look at the range. When I marked, we did not start where we start. So you cannot combine them. So yeah, in the final exam, expect to see one of these. And definitely in class exam, you'll have one of these. Any question? So are you sure you guys have no question about your journey to anywhere? No? You should try doing the homework on section 3.6. Probably the homework has few other examples. They might be helpful. Okay, so that's how we read our graph. From the graph, we figure out what is our domain and what is our range. Now, what if they do not give us the graph? They just give us the equation. Well, in this class, we are going to have 4 types of equations. One is just normal polynomial. One is add root function. One is even root function, mostly square root function. And one is rational, sorry, not 4, we have more. Oh, no, 4. It is so likely. In pre-calculus, we are going to have 8 types of function. But here is only 4. So depending on the function, our domain and range are different. Good news, we didn't have to find the range for this. We only need to find the range. How do you find domain? You start by asking yourself question, which x values we cannot find? If you can figure that out, that's it. So polynomial. Polynomial means anything where you don't have a negative power or your variable is not on the denominator. something like y equals x squared, y equals x to the 100 minus 5x squared, or y to the absolute value of x, or what? Sorry, polynomial is not absolute value, my bad. Y to the, let's say, x to the 3 minus x squared plus 1, blah, blah, blah. So polynomial means all the exponent you see, they're positive, and none of the variable is on the denominator. So all the variable must have only whole number power, no fraction power, no negative power. So think about this one. Is there any problem with plugging any type of number for x? Can you plug in x with -10? We can, right? Because -10 cube is a real number. -10 square is a real number. So you have no problem. Can I plug in -million? We still can, right? -million cube is a real number. -million square is a real number. Can you plug in 0 here? What is 0 cube? 0. What is 0 square? 0. So you can plug in -million to 0. How about positive million? Can I substitute x with positive million? No. So do we have any number that we cannot plug in here? We can the cube cancel the negative. What is -1 cube? Means -1 times -1 times -1. 1 times 1, -1. It's a real number, right? Could be negative, it doesn't matter. It's a number, right? It's number on the number line. As long as you get back a number on the number line, we have no problem. So polynomial, they have no problem. They're very generous. We can substitute x with anything. So our domain is all real number, i.e. from -infinity to positive infinity. Same thing is for add root function. For now, you can ignore the add root function. Most likely you will not see any question in the final exam about add roots or in the homework. Only the book, I think, talks about that. You can ignore for now. Now let's go to the even root function, specifically square root function. Let's say you have y equals square root of x. Can you plug in x equals 0 here? What is square root of 0? 0. So it exists. We can plug in 0 here. Can you plug in 2 here? Can you plug in 4 here? Can you plug in million here? Yes. How about -1? No. We cannot. Anytime you have a -1, what? Square root means find a number, multiply the same number twice, you're going to get the same number inside. So if we have square root of -1, it means which two numbers, same number, if you multiply twice, becomes -1. Can you think of a number, the same number, you multiply twice, becomes -1? Same number. If you pick 1, it has to be 1 times 1, it's supposed to be 1, right? If you pick -1, -1 times -1 is +1. So there actually exists no real number. If you multiply the same thing twice, you get -1. So it doesn't exist. That's why square root function has one problem. We cannot have anything that makes our inside a negative number. Whatever makes the inside negative, we cannot substitute those numbers with our axis. For example, here, we cannot substitute anything that is smaller than 0, right? Because our negative starts from smaller than 0. So our domain, it starts from 0 to infinity. How about if I modify this a bit? Now can we substitute x with 0? When x is 0, we have 0 minus 1. What is 0 minus 1? Negative 1. And what is square root of negative 1? It doesn't exist. Square root of any type of negative doesn't exist in the real life. So you see, we look at what makes this thing negative. So to figure out what makes our inside negative, we take the inside function and set it bigger than or equals 0. Bigger than or equals 0. From there, we solve for x, we get our domain. So for any type of even root function, we start from the inside, take your inside thing, whatever you have, set it bigger than or equal 0. From there, solve for x. And then we have a rational. Rational means it's a fraction. So when you have a fraction, we don't care about the numerator if numerator is just a number or just one variable. Okay, we don't care about that. We only care about the denominator. For any type of fraction, by what number we cannot divide anything? We don't. So we cannot have 0 on the denominator. So anytime we have a fraction function, we go from the denominator. We take the denominator function and say, hey, that denominator cannot be 0, means not equals 0. This is not equal symbol. So we said the denominator not equal 0, we solve for us. And if you have, like I'm going to show you a bit later. So first start here. Do we have any problem for this function? Is there any number we cannot substitute for our x? For the first one. What type of function is this? 3x plus 5. What type of equation is this? What's the shape of this equation? Shape of the graph of this equation? It's a linear. Good job, Emma. It's a linear. It's a line. And a line is an upward line or downward line. How do you know? But the line, upward or downward, it doesn't depend on that line intercept. It depends on what? Slope. What's the slope of this line? Negative 2. The negative slope is which direction? Upward or downward? Downward. So it's a line that goes on downward forever and ever and ever. So what's the domain? The first equation, it's a polynomial. Polynomial means no negative power, no fraction power, no variable on the denominator. We don't have any problem. Where is my board? It's from negative to positive infinity. We don't need to do anything because it's the first thing. It's a polynomial. Your x, it doesn't have any negative power. It doesn't have any fraction power. Where our x is not on the denominator. So if you don't have these three things, it's all real number. You can substitute x with anything. But now our problem starts. We have a fraction on the denominator, fraction on the next one. So what's wrong with the fraction? Where from it start? Roger?
I think it starts 5.
No. Anytime you have a fraction, what do you do? Not 0. Our problem is with the denominator. We ignore the numerator. Whatever we have in the numerator, we don't care. Our problem is the denominator. That denominator definitely cannot be 0. Because if you have 0 in the denominator, the whole expression is undefined. So what do we have on the denominator? No, x plus 8. So this x plus 8, this whole thing cannot be 0. To solve for x, we subtract 8. So x cannot be which number? -8. So we can substitute our x with any number except for that number, -8. So if you draw in the number line, from negative to positive infinity, you can substitute it anything, but there's only one number, -8, that we cannot definitely substitute our x with. So you can substitute anything before -8, right? Anything after -8, but definitely cannot with -8. So how are you going to write the interval? Not bracket. Bracket means you can. So from -infinity to -8, any number you have here, we can substitute x with those. But we cannot substitute x with -8, so it's parentheses. Parentheses means we cannot substitute.
So is it like saying that?
True.
So why would I give two? Altogether, two like I said, one at the top and one at the bottom.
Whatever we have on the top, as long as it's not a square root, we don't care.
Sorry.
What do you mean?
Let's see if x plus 6. Yeah,
X plus 6 over x plus 8. This x plus 6 in the numerator, we don't care. So ignore, completely ignore. We always observe the denominator. What number makes the denominator 0? Karen? You cannot, because you have to stop at -8. Before we start, but we started at the same place, so we have an open circle and closed circle at the same time. But this time we don't have open and close at the same time. You walk from -infinity and it definitely stop at -8. And it cannot take the -8. So you have to go around -8 and then start your journey. So that is cross. You definitely cannot put your foot in there. You have to go around -8. Okay, another denominator. And this time we have more, right? But it doesn't matter. Our problem is always with the denominator. We definitely don't want that thing to be what number? 0. So denominator definitely cannot be 0. So 28 minus 7x squared definitely cannot give us the result 0. And now solve for x. What is our step one to solve for us? Hmm?
Oh, yeah.
Our goal is to get the x alone.
Subtract, so, yeah, -28,
Okay.
and then divide by -7.
Perfect. So we are going to subtract 28, but you have to do more. So negative 7x squared. We divide by negative 7, negative 7. So x squared cannot be which number? X squared, 4.
And then X.
Before we do any math, find that. Think about this. Which number square is 4?
-2.
Also,
See? There are two numbers you cannot have. So x cannot be a +2 or a -2. So there are two numbers we definitely cannot substitute it. So negative infinity, positive infinity, we can use anything, but we cannot use -2 and +2. So between them, before them, after them, take any number, but we cannot take this two. So what's the domain? Negative infinity to -2. Then the next journey, you have to turn around -2, go 2 until 2, and then it turn around and then start your journey again. +2 to infinity. This is for number interval notation, this is graph, and this is for inequality notation. In the exam, usually it's final it's interval notation. So anytime you have any type of denominator, your first step is denominator cannot be 0. So denominator not equal 0, solve for your x. Who is confused? Anyone? No. So in our next class, I'm going to ask one of these. These are the final exam questions. Now comes the third type of problem, square root. Square root says whatever we have inside the square root, that thing must be either 0 or positive. We definitely cannot have anything negative inside the square root, right? If you have a negative inside the square root, it doesn't exist. You cannot, because that you cannot find the domain. You're not solving for x. You're finding domain. So problem is here. So function inside the root equals 0 or bigger than 0. Not only 0, it could be bigger than 0 means positive. 0 to infinity? No. Think about 0. Why is 0? It's 1, right? But can't you take anything before 0?
This is equal.
Okay, I said function inside the square root has to be bigger than 0 or equal 0. What function you have inside the radical? 2x plus 1. So 2x plus 1 either bigger than 0 or equal 0. And now solve for x. Minus 1, minus 1. 2x is bigger than or equal 1, negative 1. Divided by 2. So your x starts from which number? Negative 1/2. So you see, sometimes you can substitute x with negative numbers. It doesn't matter. Why not? Because we want the overall thing. The overall result cannot be 0. So it cannot be negative. When our x is negative 1/2, look at the y value. It's 2 times negative 1/2 plus 1. 2 cancel out. We have negative 1 plus 1. Y is 0. It's a real number. Here. Y x is negative 1/2. What is our y? Our y is 2 times negative 1/2 plus 1. The 2 cancel out. We have negative 1 plus 1, 0. This is a real number. So you see, even when x is negative, we still have real y numbers. So that's why I cannot say x cannot be negative. No, it's not true. The function inside the x, that cannot be negative.
So whenever you see square root, just plug that number in and then greater than.
Not number, the equation.
Equation.
Set the equation bigger than or equal 0. And can you give me the interval notation for this? True. It's because you start your journey from negative 1/2 and you're allowed to use negative 1/2. When you use negative 1/2, you still have a valid number for your y. So you can use negative 1/2 and you can take any number that is bigger than negative 1/2. So our interval notation is starting from negative 1/2, including negative 1/2 for bracket. It doesn't look like bracket, it is bracket, okay? Bracket all the way to everything we have to infinity. Nicholas, question. You're fine? You just asked him your question, why not ask me?
I was still confused on.
Right, I did that to show you that when our x is negative 1/2, we still have a valid number for y. So this is to show you that we can work with negative 1/2. You don't need to do this in your domain, but I showed you to show you that yes, x can be negative. The result cannot be negative. Any question? So in the next class, I'm gonna give you one of these in the quiz. Find the domain of the function.
There's one more.
There is one more when you have square under the square root. But I will leave that for the next class. Because this is that plus more. So yeah, I'm going to let you go early. Don't forget to do your homework, guys. The first set of homework is due on 15th or something. Huh? Give you a response. So the coordinator said, can me any calculation can be driving moving. Who's if in the minor right side, right here is the right side, right side, no, in the right side, only looking out. Wait, and here. So he told me to tell you guys, if you need, to give back 24-month access before, send him a confirmation email that you got it. It's that Timothy that right now at Baruch, it's in our My Club, so it's in our right space. Send him the email, you will keep the code. This feedback including cannot make it, you can have this class, then you still have a chance to the lesson start and even to do it. And if you buy the continuous, the next semester you're gonna buy again. If you cannot just the next semester you have to buy again. Okay? 24 months means you are safe for 2 years. It means 4 months, sorry, 4 semesters. You're safe for 4 semesters.
So did they just recently change it to 16?
Yeah,
They lowered their requirement to 16. It was like 70.
well, no, they're not about the time.
No, I'm talking about like, did they lower their requirement? Because I was exceeding.
Previously it was you're about, but from this semester.
Why did they change brands? If you're trying to get us. Like the beginning part, yeah, beginning part, like I was not.
Yeah. I think so.
Yeah, like everything before this was easy. Like the end of it was easy, but like at the beginning of this, yeah, like the first couple ones, beginning stage. No, she got. Should be both. Yeah.
You should be safe for the in-laws. They clean the trash bag once a month. But the in-laws stays intact for a long time. The possible one to is between.
You changed the dates?
No,
It was always like that?
Yeah.
Oh, well, I haven't had access.
the first 5 were the go to Gmail, the trash box has PS1. And then whatever you use on PS1, you keep that list and create is information.
So you got price space. I just sent him like a
Forward that email to his email.
Yeah, he's pretty quick to respond.
Yeah.
He got me my code this week. I just sent him a screenshot.
Screenshot is not called now. Because he needs to see all the details. Try sending a screenshot. If it doesn't work, then we'll just forward that.
The meat doesn't really buy the voice of my mom every time. So the meeting also talking about like externally.
The registration attempts.
I tried multiple times.
Things of
Like I tried paying for it, I tried getting the free one. It was like trial, doesn't work.
You should prove it.
Well, yeah, I know.
forward that to Timothy.
I have a question. Are you going to review for example?
My plan is to do that.
Let's see. Can't review all. Respond to first.
No, No, they will be good. Come early. Come early next time.
I try to.
Okay? Yeah. So next time come from your home, get out even earlier than that.
I didn't know the trains work. I get off at the same time.
Now you know it doesn't work, right?
You said this is gonna be a quiz.
Yeah, in the next quiz, which is Thursday, I'm going to ask one of these, find the domain.
For the first exam, like, they thought your review sheet on Brightspace, right?
Study the review sheet, everything, you'll be fine.
Well, you post all the lecture on your YouTube. Because one time I was late, so I'm like, watch it.
Yeah.
Awesome, it's for like,
Yeah.
then like, it's like extra work that I could do. Because I know
No. but
extra
this
credit, like.
No,
like,
we're not
challenge
actually
questions.
allowed to give any,